In my previous tutorial, I applied this calculated dead and live load shown on the screen on our structural model in Orion software. I also explained how I computed the dead and live load in one of my previous tutorials. In this tutorial session, I'm going to explain the loading for the quarter ton staircase, the quarter ton staircase beams. The quarter ton staircase beam is the stair on the left hand side of my structure, and if I should go to AutoCAD, this is my first floor GA. This is the quarter ton staircase area. As you can see, it has three flights. You ascend, have a quarter ton, you have a landing here. I'll call it a quarter landing. There's another flight here, a flight of three risers. Then under quarter landing, then you ascend this flight to get to another floor. So we have three flight and two quarter landing. So how do we compute the load of this element on our staircase beam? The staircase is supported by four beams. This beam along the line D, this beam here, and the beam along the line 2, the beam along the line 1, and also the beam along the line C. So how do we determine the load carried by each of the beam? I'm going to explain that to you with this calculation that is shown on your screen. So the loading for quarter ton staircase beams. So we start from the flights. What we did for the half ton staircase, we calculate the loading for the flight and the half landing, and then we also compute the area of the flight and area of the plan area of the flight and plan area of the landing, and we use it to compute our dead and live load for each of the beam. So for the flight, we have our weight slab by using a 200 slab. So our weight will be 5 kN per meter square. Remember, 25 is the unit weight of concrete, which I've specified to be 25. The step is the weight of each of the I've explained this to you in my previous tutorial, but I will show you again. If I should draw a line, say from here, from this riser to this riser, the weight of the element above this line, these triangles are my steps. So, how do we? I want to compute the weight of each of these elements. The element below the line is my waist, and the waist is 200, and I already computed that. So these triangular elements are my step. So the waist is the element below that line, and it's 200 mm, 5 kN per meter square. The step is the element above the line. So you compute it, you compute it by saying the half of the riser times the unit weight of concrete. The riser is 155 mm. So you compute this to get the weight. Finishes, I say it's 0.6 kN per meter square. So if you should add the steps plus finishes to get this value, 1.938 plus 0.6 to get this value. You need to calculate your slope factor given by this. So live load is this. So dead load for plant area will be the weight of the waste slab, which is 5. We need to multiply this step plus finishes by slope factor. So the slope factor times the weight of the steps plus finishes. Step plus finishes is 2.538. That's why 2.538 is there. So this dead load on plan area is this. So the square area for the flight, I will show you how to compute the square area for the flight for this quarter ton staircase. I'll go to my AutoCAD drawing. So this is the quarter ton staircase. I told you that we have three flights, flight 1, flight 2, flight 3. So I'm going to use the area measure command on the AutoCAD. Now I'm on the command, but I want to add multiple areas. So the first thing I'll do, I will enter A as an add area at the bottom of the screen here. If I type A, that option will be chosen, will be available to me. So I'll press enter. So I can select multiple area and add them together now. So I'll click this point, this point, this point, this point, press enter. That's one area. This point, this point, this point, this point. Second area, the third flight now. This point, this point, this point, this point. So if I press enter again, I get my total area as 8.89. You will see that I have 8.89 here. So you can now calculate the total dead load in kilonewton. So the total dead load in kilonewton will be the area times the dead load. So the the dead load is 7.88. The square area is 8.89. So that's why we get 70.1 kilonewton here. The live load will be 5 kilonewton times the area. So we get this value. So for the quarter landings, we have two quarter landings for the stair type. So what you need to do, you need to calculate this the self weight of the slab. Our weight is 200 mm. Our unit weight of concrete is 25. So if you compute this, you get 5 kilonewton per meter square. Finishes say it's 1 kilonewton per meter square. Live load is 5 kilonewton per meter square. The square area of landing, not flight. Sorry, I made a mistake here. Square area of the landings. Square area of landing is 5.46. I calculated this on AutoCAD. I'll show you how I did it. So these are the two landing here, this area and this area. I'm going to use the measure command to measure the area now. Sorry, area. I'll enter A on my keyboard, enter to add the multiple area. So I'm adding multiple area now. This is one area, second area, press enter. So I have 5.46. So that's what I have here, 5.46. So if I should multiply the area by my dead load and live load, I get this right. I get my total dead load and total live load. My total dead load is 5 plus 1, 6 kilonewton per meter square times the area. So we have this value. Live load is 5 times the area. We have this value. So this is my assumption here. Very important statement. I said this stair is supported by 4 beams. I've showed you in the beginning of the tutorial, whereby 4 beams between each story height. I will assume the dead load and live load calculated above are shared equally between these 4 beams. So I now say that these 4 beams, they have different lengths. So I'm using an average length to distribute the load to the 4 beams. So we have let me go back to AutoCAD. So the beam along the line D, if I should use the measure command, you'll see that from grid to grid, it is 5 meters. So the beam along the line D is 5 meters. The beam along the line C is also 5 meters. The beam between the line C and D, from intersection to intersection, 4.24. 4.24. So we have 5 meter, 5 meter, 4.24, 4.24. So that's how we get our length. But I'm using average length. So that's my average length is 4.62. So I can use this average length to distribute the load between the 4 beams. So dead load carried by each of the beam. So the is the load of the dead load of the flight, dead load of the landing divided by 4, divided by the length of the length of the beam to get the load in kilonewton per meter. I want to get the uniformly distributed load on the beam. That's why I'm divided by the length. So I get this value. I do the same thing for the live load. The live load from the flight and the live load from the quarter landings. So divided by 4, divided by the length of the beams. So you get this value. So this is how I compute my dead load and live load for the 4 beams supporting the quarter ton staircase. So I'm going to impute this value quickly on my Orion 18 structural software. So I'm going to select this element first. I will right click. I will say edit beam load. So I'll create a new load. So I want to, this dialog box open. I will click the uniformly distributed load button, which is the first button where my cursor is. Then just you label the load, type anything there. Stair, I'll call it stair load. Our dead load from our calculation is 5.57. So 5.57, 5.57, and our imposed load is 3.89. 3.89. I will click OK and click OK. Once I've specified this load, I do not need to repeat the same thing for a 3 beam. What I can do after I specify the stair load on the beam, I can select this beam and copy the beam manual load, the load I just specified. I'll copy that beam manual load and I'll select the other 3 beam and I'll paste the load on it. So I'll paste copy beam load. So if I paste it, the load will be on the beam. I will select this beam to show you the load I just pasted on the beam. It's selected. I'll go to edit member load, and if you let me think this is the load there, I'm not sure. Let me edit. You see stair load. I have the value here 5.57 and 3.89 is my stair load. So I've already pasted the load on the beam. So we have achieved the objective of this tutorial. we have achieved the objective of this tutorial. In my next tutorial, I'm going to show you how to generate the information on this my floor. This story one, the beam and slab and column. I'm going to show you how to generate this information to story 2, story 3, story 4, and story 5 level. If I click on the story 2, you'll see that I don't have any beam or column or slab defined. So I'm going to show you how you automatically generate the information so that this story will have its own beam and column and slab information defined on the plan view. Thank you for watching this tutorial video.